Hi everyone. So in this video we'll see how to make a CheerBot using a WCH microcontroller instead of microbit. So the problem with microbit is like it is very costly, and for the simple example it is kind of a overkill. So we'll simply use a CH552 based microcontroller which costs like less than $1. So to make this CheerBot, like first you need to download this PDF file. So like I have printed it on a A4 sheet, and then to give it some rigidity, like I have pasted it on a chart paper using Fabric. Then I cut it across the black lines and I have folded it across the dotted lines. You can find like more instruction on OK to do website on how to build this, and you can like purchase this ready-made templates also from their website. But because it's not available in India and like my use case is different, so I have simply printed it on a A4 sheet and like will make it using that CH552 based microcontroller. So the first thing you need to do is like you have to download this code uploader installer, and I have downloaded and extracted it into a folder. And then I have like run that installer.exe, which went ahead and installed all the dependencies. So now all the dependencies has been installed. I can simply run that CodeSkool.exe, and CodeSkool is now running. So I just go and refresh this browser page. So I have already connected my device, and because I already had that WCH drivers installed, so it has detected as COM9 port. So we'll go into the board, select that CH55X, add extension. Then we have to add the Arduino extension also, and we have to go into the upload mode. I have to select that correct COM port and correct board type from here. Then I simply drag this starting block here. Now, to be honest, like I also don't remember how to program it. So we'll go and check our videos. So like this is how to use that servo motor, and this is like how to use the touch pins, and this is the signal connection for the servos. So VCC ground and signal. So I use this 5-volt ground and maybe pin 34 or something. So let's check this example. So like which pin support that touch interrupt. So like pin 10, 11, 14, 15, 16 and 17. So I might use like pin 14. Pin 14 is our touch interrupt. Pin 33 is like LED. And for servo, let's just connect it the servo on pin 34. So the servo will go on pin 34, LED is on pin 33, and touch interrupt is on pin 14. So first let me define the variable. Let me call it GPIO 33. And then I have to go and set that pin mode as output. So this will go in basically setup. Then we have to do that touch key begin. So this is the begin touch key. Maybe I can simply copy this from here, or this is the same as this, but to give it more clarity, I'll just copy it like this. Now we have the touch key begin. We have to do the touch key process in the loop. And then we have to like get the result in some variable. So let's just create another variable. So I8 is for unsigned int 8. And let me assign it to get touch key. Now you have total 6 touch pins. So like 1, 2, 3, 4, 5, 6. So this is checking like which pin has been touched. So I don't need all those things. So let me just create a simple if statement. I'll go in control, add another if. Then I have to get this, and I have to check my touch key is on pin 14. And this is my variable. So this is the setup which initializes the default LED and start the touch key initialization. Then in the loop we are processing the touch key, getting all the pins and checking if the pin 14 is touch. So if the pin 14 is touch, I might want to blink the LED. And I might want to wait for some duration. And the other thing, if it not touch, like I'll just make it low again. So when the pin is touched, like I'll just blink the LED. So this touch key initialization code, this is done. So now we have to look into how to control the servo. So for that, like I have to create a few more variables. Servo min angle, servo max angle. So let's just create those variables. Servo min angle, servo max angle, then servo min pulse width and servo max pulse width. And I have to define the servo pin also. So I'll use the servo pin as 34. So let me initialize it here itself. Servo pin as GPIO 34. And I'll initialize these other variables. One, two, three, four, angle, max angle, min pulse width, max pulse width 0, 180, 500, 2500. 0, 180, 500, 2500. So this initialization has been done. Now we have to configure the servo also. So this has initialized the LED, this has initialized that servo pin, and this has initialized the touch key. So our setup is actually done. So LED is on pin 33, servo is on pin 34, and we have enabled all the touch pins, and basically simply checking if the pin 14 is touch. Now we have to set the degrees. So we'll use the servo right. Select the servo pin. So I have to look into the documentation for CheerBot, like about their program. So this is the documentation on OKDo website. So this is what I have done so far. Then you use that servo horn and like stick it here on that arms, and then you wrap this thing around the servo and paste it here like this, and then fold it, take the wire out, so this is the code. So like I'm not connecting a microphone, I'm simply doing that tickle board kind of thing. So once finished, this will look like this. Then you can go and decorate using that another template provided. So this is what we are looking. So on this leg, like I have like pasted an aluminum foil, tin foil, basically like in India you call it like an aluminum foil, kitchen foil. That's what I have pasted it here. So this will go to our pin 14 and the servo is on pin 34. So this is what that make code is look like. So when this pin is touched, like we'll set the angle to 70 degree. So let us do that. Then we pause for like 200 millisecond. So let's change it to 200. Then I have to put another delay. I have to add another servo right. and then I'll set the angle again to 30 degree and wait for 200 milliseconds. Set it to 30 degree, and for clarity I'll use the variable servo pin. So I think this is done. Like in the loop, like we are checking for the touch key. If the touch key is pressed, we are turning on that LED for debugging purpose, and we are changing the servo angles. And if it is not pressed, we are like switching off the LED. And we have to like on setup, like set the angle to 50 degrees. So I'll add one more statement. Servo right, servo pin 50 degree. So default is 50 degree, then it will go like up 70 degree, and then it will go down like 30 degree. So that would give this kind of impression. So this is our generated program. So before compiling anything, like one of the thing you have to do is like make sure your temp directory does not have any spaces. So what I have done is like I have changed my temp directory to C drive temp, because like my username is like first name last name, and like there was a space in between, so like it was creating issues. So I have changed my temp directory. So once the temp directory is changed, like I can go and like run CodeSkool again. Then I hold the upload button on my board and click this upload button here, and this should start compiling the code. So as you can see, it has successfully uploaded the code. So this is the boot button you have to keep pressed before you click this upload button. So the cost of the project would be like 135 rupees like for the board, and like 100 rupees for that servo, and like 10 rupees for printout and wires. So like approximately like 250 to like 300 rupees, like you can make like multiple projects. So like few things to consider, like if you are having issues with the touch sensitivity, you can use set touch threshold function to adjust that sensitivity. And like another thing is like once you receive the blank board, like you have to first install that firmware. So you can like check our YouTube videos for details on like what to do if you face like compile or upload issues. So here is a quick demo. Like when I touch this pin 14, like the servo will move and this LED will blink. So as you can see, like this is that power 5 volt and ground, and this is the pin 34, and this is the pin 14 on which I will touch. So you can see like while I am touching, like it is moving, the servo arm is moving and the LED is on. And if I remove my finger, the LED is off, and like servo will also stop rotating. This is the CH552 board, and I have connected the pin to its leg using copper tape. We can use aluminum foil also. So we'll just see a demo like when I touch the legs, its arm will like rotate. So it is detecting like disturbance in electromagnetic field, and like uh, even if you like take it near, it will automatically start. So I hope you like this video. Thanks for watching.